Alright, so now determining limits graphically. This is one of my favorite ways to determine limits. It's really very, very simple if you get the hang of it. So make sure you're sort of paying close attention to this. Before I get into this, I sort of want to talk about two concepts with graphs that one we already should know, and one, if you don't already know it, we'll review it now. First of all, I want you to remember, in some of our previous lessons, we said that graphing a function was like super evaluating the function. When you look at a graph, it's telling you all sorts of values all over the place. So for instance, if I give you a graph that looks like this, right? And if this is 1 and this is 1, every single one of these points along the graph is telling you when you plugged in this, you got back this. When you plugged in this, you got back this. When you plugged in this, you got back this. By looking at a graph, you are seeing infinitely many evaluations of the function all at once. So when we talk about determining a limit graphically, we're going to be looking at the graph and remembering this thing is recording when you input these x values, you get back these y values. And so we're going to be using that. Now, the other thing that we need to know about graphs is we need to know what a hole in a graph is. And I feel like that's a place that you guys may have learned a little bit about, but not a lot about. So I'm going to draw a picture of a graph that has a hole in it. So let's say you've got your axes here, and then you've got a function that has a hole right there. The question is, what does that hole mean? What it means is that for this x value right here, whatever this x value is, the function is not defined. It means when you try to plug in, like let's just say, for instance, let's say this x value is 2. When you plug in 2, the function doesn't work. It's missing a point, right? Every other point nearby works fine, right? And so it's sort of funny, that hole that I put there is like huge, right? I mean, if I were to sort of zoom in on this, we could even go in and say, no, the hole is really kind of right there. And even that doesn't do it justice. We should really be sort of zooming in even further and saying, no, the hole is really, really right in the middle of here, right? When we zoom out, though, I mean, like if I were to draw that, you wouldn't be able to tell where the hole was. So when we put a hole, it may look like there's a lot of points missing, but that hole really means there is only one point that's missing. Every other point nearby is there. So that's what a hole in a function means. So for the rest of this video, I just want to go through some examples of how we evaluate these things. So we're going to start with some practice just with evaluating functions. So I'm going to go through one of these with you guys, and then I'll have you do the other two on your own. So we're first looking at these evaluations of functions up here. So if this thing over here on the left is the function y equals f of x, right, I could ask, what is f of 1? In other words, when you plug in 1, what do you get? So when we look at this graph, we say, well, when I go over 1, the point is up here at 1. That means that f of 1 is 1. Okay. I'd like you guys now to pause the video and evaluate what is f of negative 2 and what is f of 3. Okay. So f of negative 2, when I go on my graph back here to negative 2 and I look for where the point is, we notice there is no point. Now you might say, well, it kind of looks like it's 3. That's true, but there's a hole there. It means that when you plugged in negative 2, this graph did not work. So f of negative 2, we would say, is undefined. And what that means is that the function is literally not defined. There is no definition for what happens when you plug in negative 2. Right? Now what about f of 3? F of 3 is kind of weird, because you've sort of got the function going up towards this way, and then it sort of comes out on this side. But at 3, remember this means at the value. At 3, the value of the function is down here. That value is negative 2. Right? So f of positive 3 is negative 2. Now the rest of these are limit questions. Right? And remember that for a limit, what you're doing is you're looking at, as you approach the x value, what is the function doing? So this first question here is not saying what happens at negative 2. We already know at negative 2 it's undefined. It blows up, like weird things happen at negative 2. This question is saying, as you get close to negative 2, what are the values of the function doing? And so there's a part of me that sort of wants to say, like, all right, well, let's zoom in on this graph near negative 2, right? As I plug in x values that get closer and closer and closer to 2, so as I plug in negative 1 and get this point, as I plug in negative 1.5 and get this, negative 1.9 and get this, negative 1.99 and get this, what's happening to the values of this function? It looks like these values are coming up towards 3. And what's more is that it's doing it from both sides. From the right, I'm approaching 3, and from the left, my values are approaching 3. As my x values approach negative 2 from both sides, my y values are approaching 3. And so when we answer this question, right, when we answer the question of, what is the limit as x approaches 2, we can say that that limit is 3. Because as I get closer to negative 2, the value of the function gets closer to 3. Okay? Let's take a look at one more of these together, and then I'll give you the rest of them to try on your own. So next, let's look at B over here. The limit as x approaches 1 of f of x. Right, so again, we can sort of like focus our attention in on what happens as I approach 1. So as my x values approach 1, well, as I approach 1 from this side, what are these y values approaching? As I, plug in this value and get this, plug in this value and get 2, plug in this value and get 1.1, these values here are approaching 1. But from the right, these values, as I plug in 2, and then plug in 1.5, plug in 1.3, 1.2, 1.1, these values are getting closer to negative 1. So in this case, the left-sided limit and the right-side limit are not equal. The left-side limit is 1, the right-side limit is negative 1, and because of that, this limit does not exist, right? So we would say that this limit, and sometimes we'll use the shorthand dne, so we'll say the limit does not exist, and that's what that one is. So at this point, I'd like you guys to, I'd like you guys to go through these other 4 problems. So go through C, D, E, and F, use the graph that I provided, and determine what those limits are. Okay, I'm not going to go into quite as much detail on these ones because I want to keep this video shorter, but we'll go through these now. So the limit as x approaches 3. As I approach 3, the left side is approaching 3, the right side is approaching 1. Because of that, this limit does not exist. Okay. The next one says, what's the limit as x approaches negative 2 from the right? Okay. So the limit as x approaches negative 2 from the right of that function. So let's hear negative 2. Here's negative 2. From the right, okay, so from the right, I'm approaching a value of 3. It just occurred to me that on your screens, these values may be really small, so if you weren't able to read those ones, I'll sort of zoom these in so you can see them better. If you didn't get a chance to do E and F because they were too small, hopefully you can see them now. So pause the video, I'll zoom back out so you can see the graph. This one is the limit as x approaches 3 from the left. This is the limit as x approaches 1 from the right. So pause the video, take a look at this graph, and evaluate what those two limits should be. Okay, so the first one we need to do is the limit as x approaches 3 from the left. So here's 3. As I approach 3 from the left, that value that I'm reaching up here is positive 3. So this limit is 3. Okay. Then the other one that we need to do is the limit as x approaches 1 from the right. Okay, so if I approach 1 from the right, here's 1. If I approach it from the right, even though there's a point missing there, as I get closer and closer and closer to 1, my y values here are getting closer and closer to negative 1. So the value of this limit is negative 1. To be honest, that's almost all there is to evaluating these limits graphically. You look at the graph, you look at where the pieces are going, and you make a statement about what the limit is.